Hello, everyone. Today we have this particular question. Now let's read to the following question. Give three different alternatives to handle the ends of a 3D vortex filament in the Helmholtz vortex theorem. Once again, give three different alternatives to handle the ends of 3D vortex filament in the Helmholtz vortex theorem. First of all, what is vortex theorem? Vortex theorem states that in an inviscid, an incompressible fluid, the circulation around a closed curve is constant in time. When considering the 3D vortex filament, there are several alternatives to handle its ends. The first one is what we call the closed loop. This is the first alternative, which state that or make an assumption that the vortex filament forms a closed loop. And what does it mean? It means that both ends of the filament are connected. This approach simplifies the analysis by providing a well-defined starting and ending point for the filament. It also allows for the application of Helmholtz vortex theorem to the entire closed loop, enabling the circulation and the study of its property. So therefore, the first alternative is closed loop, which telling us that the both ends of the filament are connected together. Number two alternative, infinite extension. These are another alternative to consider the vortex filament as infinitely extending in the space where the ends of the filament extend to infinity. This assumption is often allowed and employed when studying far-field effect of vortices or when they're analyzing the vortices in unbounding flows. By assuming infinite extension, the effect of the ends of the filament are neglected, and the focus is placed on the behavior of the filament within the flow region of interest. So in the second alternative, it is assumed that the vortex filament has infinite extending in space is assumed and chosen. That is, we consider the vortex filament as infinitely extending in the space. The last but the least, which is the third alternative, is what we call free end. In this case, the Helmholtz vortex theory is considering the free ends of the vortex filament explicitly. This can be done by accounting for the induced velocity and the vorticity shared at the end of the filament. This approach requires additional consideration and modeling to capture the dynamics of the free ends accurately. For the example, shading of the vorticity of the end of the filament can be modeled using vortex ring or through consideration of the vortex filament with variable circulation. The choice of how to handle the ends of the 3D vortex filament depends on the specific problem being studied and the level of detail required in the analysis. Each alternative has its advantages and limitations, and the appropriate choice should be based on the physical phenomenon under investigation and the mathematical simplification desired. So therefore, the three different alternatives to handle the ends of the 3D vortex filament using the Helmholtz vortex theorem is one, the closed loop. That is to say, assuming that the vortex, assuming that the vortex filament are connected. Then number two, assuming that the extension is infinite in the space. Then number three, assuming that the free ends is considered for the vortex filament in a explicit status. Thank you for staying tuned and listening.